Okay, in the last video I mentioned that there is heterogeneous materials and homogeneous materials. We're going to start talking about heterogeneous materials. Heterogeneous materials are also known as heterogeneous mixtures. They're non-uniform. You can see different parts. Sometimes in order to see those parts, though, you may need a microscope. I'll just give you some examples, though, of ones we can see. Concrete. There is sand, gravel, and then the lime and the clay. Salsa. Onions, peppers, tomatoes, cilantro. Even pizza is a heterogeneous mixture. You have the crust, you have the sauce, you have the cheese, you have your pepperoni, and your sausage. Phases. In heterogeneous materials, there are phases. There's physically separate parts. It's like in concrete, the sand, the gravel, the lime, the clay are each their own phase because they have their own set of chemical properties. When one phase touches another, we can call that an interphase. Like the sand touching the gravel is an interphase, the sand-lime interphase, the gravel-lime interphase, or if we're talking the salsa, the onion-pepper interphase, the onion-tomato interphase, the onion-cilantro interphase, the pepper-tomato interphase, the pepper-cilantro interphase, and so forth. Okay, homogeneous materials, a little bit more complicated. Homogeneous means the same or the uniform. So there's uniform distribution of particles within the material. There's only one phase because we cannot tell apart the other ones. We can't see that there's more than one thing there, even if we have a microscope. For example, salt is its own. Yes, it's made up of sodium, it's made up of chloride, but we can't see that. Salt water, if we dissolve salt into water, we cannot see the salt in the water even in the microscope, so it's homogeneous. Air's homogeneous. Sugar's homogeneous. It's all the same even if broken down into smaller pieces. Okay. Homogeneous mixtures. Homogeneous mixtures, aka solutions. You could use the word homogeneous mixtures, you could use the word solutions, it's going to mean the same thing. Okay, so again, they're homogeneous. You cannot tell the difference between the different parts. With a solution, aka homogeneous mixture, you have the dissolved material known as the solute, sugar, salt, flour. You have the dissolving material, which is known as the solvent, which could be water or milk. Now, you don't have to have the solute being a solid and the solvent being a liquid. They could be two liquids, and I'm going to demonstrate that for you in class. The compositions of these can change. I can add, let's say, 10 grams of water with 5 grams of salt. Okay, we still have a solution of salt water. Or I could have 100 grams of water with 20 grams of salt. It's still salt water, it's still homogeneous, because I cannot see the different parts. So the composition of solutions can change, and it still be that solution, and it's still homogeneous. Okay, the amount of solute in a specific amount of solution is known as a mole. And we're going to have a whole chapter later on devoted just to moles. But so for example, so if we have 5 grams of salt in a 100 milliliter solution of salt water would be an example of that. But again, we have a whole chapter devoted to moles, so I'm not going to spend time on it now. Then there is the word substance. It's still a homogeneous material. Substances are homogeneous materials. Okay, we cannot see the different parts, but the composition has to stay the same to be that substance. Material with definite composition and properties is the definition for substance. Material with definite composition and properties. Composed of atoms of 2 or more elements are known as compounds. If it only has one type of atom, it's then an element. So, an example of a substance would be a compound or element. Compound or element. The composition has to stay the same. Okay, so let's say like H2O. That's water. H2O2 is not water. So the big difference between substances in solutions is solutions, their compositions can vary and it still be that homogeneous material. Substances have to stay the same. If you have H2O, that's water. H2O2 is not water, it's hydrogen peroxide. So the substances, or the materials it's made of, have to stay the same. Now, if you are a person who's going to study carbon, then you are studying an organic substance. And usually the carbon has to be hooked with hydrogens and oxygens. And we're talking about living things here. So organic substance, there's organic chemistry. So there's a whole chemistry devoted to organic substances or compound or carbons mixing with other elements, usually hydrogen and oxygen. Then there's inorganic substances, and there's a whole chemistry devoted to this. It's inorganic chemistry, and those are compounds that do not have carbon involved, like hydrochloric acid and NaCl, which is salt. I do have on the website a diagram that breaks down all of this matter into a nice flow chart, and it is the classification of matter by composition. Now let's see if you can pick out some examples. I would pause the video right now, and if you did not print out the PowerPoint, then you could write down all of these and then tell me whether it's an element, a compound, a heterogeneous mixture, or a solution, aka homogeneous mixture. So pause the video, and then when you come back, we'll go through answers. Okay, so ocean water would be a solution because it's salt water. It's uniform. We cannot see the different parts, and we could add more salt and it'd still be salt water. We could add more water, it's still salt water, but it's homogeneous. Calcium is an element. Hamburger, heterogeneous mixture. You have the fat, you have the meat part, gristle. Aluminum foil is an element. Aluminum is an element. Milk, if we're talking whole milk, and I think either skim milk, you have a heterogeneous mixture. You may need the microscope to actually see some of the parts. Table salt is a compound. Air is a solution. Corn syrup is a compound. Corn syrup is liquid sugar, and sugar is C6H12O6. It has to be C6H12O6 or it's not sugar anymore.